Question 13. Press Doc 4 for insert, 1 or enter for new problem, and add a calculator page. In part A, you're asked to determine an equation expressing z squared in terms of y squared. So using Pythagoras' theorem, z squared equals y squared plus 50 squared. In part B, you're asked to state the value of dy dt. The first sentence says that the drone travels vertically from point A at a constant speed of 8 meters per second. So dy dt is equal to 8. And then we're asked to use parts A and B to determine the rate at which Z is increasing with respect to time when the drone is 20 meters above point A. So what we need to do is we need to find dz dt, given that y equals 20, and we know that dz dt is dz dy dt. So let's form that expression and then substitute y equals 20 into it. So control divided by, and then the fraction of a half multiplied by, open bracket, y squared plus 50 squared, arrow to the right, raise that to the power of -1/2, and then multiply by the derivative inside. So that is, open bracket, 2 times y, close bracket. So that's dz dy, and now dy dt is 8, so we'll multiply by 8. Then control equals arrow to the left to get the with or given symbol, and we want to substitute y equals 20 into there. If we press enter now, we'll get an exact answer. So if we press control enter, we get correct to 2 decimal places, 2.97. And so the rate at which Z is increasing with respect to time at that point is 2.97 meters per second. Question 14. Press Doc 4 for insert, 1 or enter for new problem, and add a calculator. So press enter. In part A, we can assume this because the population from which the random sample is taken is normally distributed. In part B, we're asked to determine that the probability that the mean height of this sample will be greater than 170 centimeters. So we'll press menu, 5 for probability, 5 for distributions, 2 for normal CDF. The lower bound is 170. Press tab. The upper bound, if we press the pi button and scroll across to highlight infinity, press enter, press tab again. The mean is 168.6, and press tab, and the standard deviation is 12.7 divided by the sample size, and that is 20. So we divide by the square root of 20. Press tab to highlight OK, and then press enter. And so the required probability that the mean height of this sample will be greater than 170 centimeters is 0.3110, correct to 4 decimal places. We're told that there's a 75% probability that the mean height of this sample will lie within plus or minus 8 centimeters of the population mean. We're asked to determine the probability that x bar is greater than or equal to 168.6 plus h. So we use the symmetry of the normal distribution curve here. The total area is 1. We subtract from that 0.75 and then divide all that by 2. And so therefore that required probability in part C is equal to 0.125. In part D, we are asked to use the result from part C to determine the value of H. So what we need to do now is we need to find the critical value, if you like, and equate it to 168.6 plus H. To do that, we use the inverse normal command. So we'll press menu, 5 for probability, 5 for distributions, 3 for inverse normal. Now, that required probability in part C was 0.125. So the inverse normal, the area that we need to enter here is to the left of that. So that's 0.875 or 1 minus 0.125. Press tab. The mean is 168.6. Press tab. And the standard deviation is 12.7 divided by the square root of 20. Press tab to highlight OK and press enter. And so we get a value which we can equate to 168.6 of 171.86, etc. So therefore, if we go up and grab that answer and then subtract from it 168.6, press enter, we can determine that the value of H, correct to 2 decimal places, is 3.27. Question 15, press doc, 4 for insert, 1 or enter for problem, at a calculator page. In part A, we're asked to show that particle A passes through that 0.5, -3, -8. So what we need to do is let's get the numerical solve command pasted onto an entry line. So press menu, 3 for algebra, 1 or enter for numerical solve. And then what we want to do is we want to equate 4t minus 9, which is the I component of vector RA, and equate it to the x coordinate of P, which is 5. And then we solve that with respect to t. Press enter, and we get a t value of 3.5. Let's do the same now for the j component of vector RA and the y component. So menu, 3 for algebra, 1 or enter for numerical solve. And so -2 multiplied by 5 minus t. I'll just go back there and change that to -2. So like so. And then we equate that to equal -3 and solve that for t and press enter. We should get the same t value, and we do. And given that we've got 2 t values that are both the same, in this instance 3.5, we can therefore conclude that particle P particle A passes through P. Okay. In part B, given that particle B also passes through point P, determine the value of A. So in this instance, we press menu, 3 for algebra, 1 or enter for numerical solve. And this time, what we'll do is we'll equate the I component of vector RB. So that's t squared plus 1, like so. And we'll set that equal to 5. And we will solve for t. So this is a quadratic. So there's 2 solutions. We only want the positive one. So press Control equals, there's the width or the given symbol. Paste that into the entry line, and then add the domain constraint t is greater than or equal to 0. Press enter, and so we get a t value of 2. And then what we do now is we can substitute that value of t to find the value of A. So we press menu, 3 for algebra, 1 or enter for numerical solve, and we will solve 4 minus A. multiplied by 2 squared. So we're substituting in the value of t, which is 2. And then we will equate that to -8 and solve for a, comma, a. Press enter, and we get a equals 3. In part C, we're asked to determine the vector that represents the displacement of particle B relative to particle A during the given time of motion. And we're asked to express our answer in simplest form. So what we do is we form the vector RB minus vector RA, and that's equal to t squared minus 4t plus 10i plus 7 minus 2tj plus 12 minus 3t squared k. In part D, we're asked to use part C to determine the shortest or minimum distance between the two particles during the given time of motion. So what we'll do is we will say, well, okay, let's let vector RB minus vector RA, we'll let that be a d of t. So d, open bracket, t, and we'll assign that. So we'll press Control, symbols template to get the assign command. Press the catalog, select the m by n matrix template, and we want to create a column vector. 3 rows is good. Press tab, 1 column, press tab to highlight OK and press enter. And then what we want to do is we want to enter in the components. So the I component, t squared minus 4 times t plus 10. Then the j component, 7 minus 2 times t. And the k component, 12 minus 3 times t squared, and press enter. So that's d of t. Now the quickest way to do this is to add a graphs page. So press Control Doc and add a graphs page. And what we want to do is we want to graph the absolute value, or the in TI-nspire language, the norm of that vector. So what we can do is we can type in norm, so N-O-R-M, and then open bracket. We can't use t here, so we'll use d of x, and then arrow to the right. And also be aware that really x is, in this instance t if you like, is greater than or equal to 0. So what we'll do is we'll put in the greater than or equal sign. So we'll type in, so given, then x greater than or equal to 0, like so, and then press enter. Now we can't see anything. That's because we need a suitable window. So if we press menu and then go to window zoom, so press 4, window settings, 1 or enter. So something like an x min of 1, x max of 10 is fine. Go up in ones if you like, press tab. Something like -50 for y min, and then press tab, and a y max of 200. Y scale of 50, something like that would be fine. And then press enter. And up comes the graph, all good. So what we want to do is we want to find the coordinates of that minimum point there. So press menu, 6 for analyze graph, 2 for minimum, lower bound, upper bound. And what we can see there is that the minimum occurs at t equals 2.0 4 corrected 2 decimal places seconds, and the y coordinate there, if you like, is the minimum distance. And so the shortest or minimum distance corrected 2 decimal places is 6.69. Question 16, press doc, 4 for insert, 1 or enter for new problem. This time what we'll do is we'll add a graphs page, so press 2. Now in this question, we're given 2 subsets of the complex plane. So S is a circle of radius 4 with center 1, 0. T is a half line or ray starting at but not including 0, -1, and it makes an angle of pi on 3 with the positive direction of the real axis. So our 2 Cartesian equations are x minus 1 all squared plus y squared equals 16, and y equals root 3x minus 1, where x is greater than 0. So what we'll do is we'll plot these two and then find the point of intersection. So press menu, 3 for graph entry edit, 2 for relation. And what we'll do now is we'll enter in the equation of the circle. So that's x minus 1 squared plus y squared equals 16. And then press enter. And our second Cartesian equation, we need to be in function graphing mode this time. So we'll press menu, 3 for graph entry edit, 1 for function. And we'll type in the square root of 3 multiplied by x minus 1, and then control equals with or given symbol, given x is greater than 0, press enter. Okay, so what we see there is we've got a point of intersection in the first quadrant, so we need to find the coordinates of that. So what we do is press menu, 8 for geometry, 1 or enter for points and lines, 4 for intersection points, and then click on the first graph, click on the second graph, press escape, and so that's our point of intersection. And so the complex number where S and T intersect, correct 2 decimal places, is 2.67 plus 3.63i. Question 17, press doc, 4 for insert, 1 or enter for problem. Press enter. TI-nspire can't be used in question 17. So what you do is you differentiate once to find the velocity vector and then find v squared, and what you'll find is that v squared equals r squared omega squared. Differentiate v again to find a and then find the magnitude of a. The magnitude of a is given by r omega squared. Now take that r omega squared and rewrite it as r squared omega squared on r, and you know that v squared is r squared omega squared, so therefore the magnitude of a is equal to v squared on r, and that's how you prove the result there in question 17. Question 18, press doc, 4 for insert, 1 or enter to insert problem, and 1 or enter to add a calculator. So we need to form 3 equations here. From the first diagram, we can form the equation 4 minus mu on sigma is equal to the inverse normal of 0.2. And as a decimal, that's negative 0.8416, etc. From the second diagram, we can form a second equation, and that second equation is 6 minus mu on sigma on root n is equal to the inverse normal of 0.8. which as a decimal is 0.8416, etc. And from the stem, we're given that the probability that X bar lies between 4 and 6 is approximately equal to 0.77. So from that, we can glean that the probability that X bar lies between 4 and mu is 0.77 minus 0.3, which is approximately 0.47. Multiply that by 2 to get an area of 0.94. And then what we can do is we can equate 4 minus mu on sigma on root n to equal the inverse normal of 0.03, which as a decimal is negative 0.18807. So from equations 2 and 3, they both have a denominator of sigma on root n. So if we perform the operation of equation 2 divided by equation 3, what we can do is we can eliminate that sigma on root n. We've got too many unknowns. What we need to do is we need to form two equations, or have two equations just involving mu and sigma. So when we do that, when we form equation 2 divided by equation 3, the other thing I'm going to do is I'm going to switch on Inspire. I'm not going to use mu and sigma. I'm going to use m and s. And so what we're going to do to be able to preserve continuity in the calculation, I'm going to assign m and s to be the solutions to these equations. So m, control symbols template, we'll assign that to be equal to menu, 3 for algebra, 1 or enter for numerical solve, then control divided by, and we'll type in here 6 minus m for the numerator, and for the denominator 4 minus m, and we'll set that equal to another fraction. And in this instance, I'm going to type out inv norm, like so. So what we want here is the inverse normal of 0.8. You don't need to add anything else because it's assumed from this that we're dealing with standard normal variable z. And then down in the denominator, we're going to type in inv norm and then open bracket. And this one is 0.03. And what we want to do there is we want to solve for m, so comma m, press enter, and we get a mean of 5.38, etc., etc. Now we're going to do something similar to find sigma, which I'm going to call s, and I'm going to use the equation 1. So s, control symbols templates for the assign command, and then menu, 3 for algebra, 1 or enter for numerical solve, control divided by, and here we're going to type in 4 minus m on s is equal to the inverse normal, or inv norm, open bracket, of 0.2, and we're going to solve that equation for s, so comma s, press enter, and we get a standard deviation of 1.64, etc. Now we're asked to find the probability that random variable a capital X lies between 4 and 6. So what we do now is we press menu, 5 for probability, 5 for distributions, 2 for normal CDF. Our lower bound is 4, upper bound is 6. Press tab. Our mean is m, press tab. Our standard deviation is S. Press tab to highlight OK, and then press enter. And so that required probability, correct to 4 decimal places, is 0.4468. Question 19, press dock, 4 for insert, 1 or enter for new problem, number 2 for add graphs. Here what we have is we want to let X be the birth rate for stage 1 females and let Y be the survival rate for stage 1 females and stage 2 females. We can therefore define our Leslie matrix to be a 2 by 2 matrix. In row 1, the elements are X, 2X, and in row 2, the elements are Y, 0. From the table, P0 is the column matrix 4832, and also from the table, column matrix P2 is 2521. We also know that P2 is L squared P0, so calculate L squared P0, and then what we need to do is set that equal to P2. And what you end up with is you end up with two relations. So if we use relation graphing, we can graph the two relations and then find the point of intersection, and that'll give us the value of X and the value of Y. So on a graphs page, we'll press menu, 3 for graph entry edit, 2 for relation, and after performing that calculation, you end up with 112 times X squared, and then plus 96 times X times Y, and we'll set that equal to 25, and then press enter. And our second equation, so press tab, bring back the entry line, it is 112 times X times Y equals 21, and then press enter. So what we'll do now is we'll set a better window. Press menu, 4 for window zoom, 1 or enter for window settings. So let's have an X min of say 1. Press tab and an X max of 1. We can use a scale of 0.25. Press tab. Let's have a Y min of -3 and a Y max of 3 and a Y scale, say, of 0.75. Press tab to highlight OK and then press enter. And what we're interested in is we're interested in the point of intersection in this first quadrant where X and Y are both positive. So all we need to do now is press menu, 8 for geometry, 1 or enter for points and lines, 4 for intersection points. Click on the first graph, click on the second graph, press escape, and our point of intersection there is 0.25, 0.75. So therefore, X is equal to 0.25 and Y is equal to 0.75. What we can do now is we can store this value as X. So press Control menu, 5 for store it as X, press enter, and then Control menu, 5 for store that as Y, press enter. Now let's add a calculator page, press Control Dock, and we'll add a calculator page. What we'll do now is we'll assign our Leslie matrix L, so L, and then Control symbols template to get the assign command. Then press the catalog button and then access the 2 by 2 matrix template, press enter. So here we type in X and then 2 times X and then Y and then 0 and then press enter. So that's our Leslie matrix. Now, we're asked to use a matrix approach to estimate the total number of females after 4 weeks. So we've got to find P4. P4 is equal to L to the power of 4 times P0. So what we'll do now is we will calculate L to the power of 4. So L to the power of 4, and then multiply that by the column matrix P0. So column matrix template in the catalog, press enter, and P0 is 4832. Press enter, and then to estimate the total number of females, what we need to do is just find the sum of those two elements. So it's even quicker probably just to type in SUM and then open bracket, go up and grab that column matrix, press enter to bring it down to a new entry line. And so we get 26.125. So the estimated total number of females after 4 weeks is 26.